So in this example, we're going to focus on subtracting with rational expressions, but we actually have both denominator with monomial terms. So let's formulate our LCD by comparing the denominators of these two fractions. Now, the first fraction has a 5, while the second fraction has a 4. So we do need a 5 and a 4 because there's nothing in common with them. The first fraction has an x, so we need to include the x in our LCD. Now, both fractions have a y, but if you examine the first fraction, it has y squared. So this is the highest order. So when you're formulating our LCD, you would go with the highest exponent. So even though they both have y's, you would go with the highest. So in this case, y squared. So when I finalize my LCD, it's going to be 20 x y squared. So again, even though they have the same variable, you would go with the highest exponent for our LCD. Alright, now let's compare the fraction with the LCD that we formulate. In the first fraction, it has the x and the y squared, but in addition it has a 5, but it does not have the 4, so I'm going to multiply the numerator and denominator by 4. So if I were to compare it to the LCD that I wrote the first time, it has a 5, the x and the y squared, just missing the 4, so I'm going to multiply the numerator and denominator by 4. Now comparing with the second fraction, it has the 4, so it's missing the 5. So I'm going to multiply the numerator and denominator by 5. In addition, it's missing the x, so I'm going to include the x. Now, this one has a y, while this one is y squared. So, in order for me to change y into y squared, I can simply just multiply by another y. So if I multiply y times y, that would become y squared. So you pay very close attention. I didn't write y squared because we already have a y in the original fraction. I just simply need to multiply by a single y. So that way these two y, when they multiply, it becomes y squared. Therefore, it will have common denominator. Now, once I examine that they both have the 4, the 5, the x, and the y squared, I can combine the numerator together as one big fraction. So it's going to be 4 times 3 minus my 3x in parentheses times 5xy. Since we're doing subtraction, you gotta be extra careful when we're distributing to the terms that you have here. And then my LCD. So you can write 5yxy squared, but I'm just gonna write it in its final form. So 20xy squared. Alright. So next I'm going to distribute, multiply where I can see in the numerator. I'm going to multiply the 4 with the 3. Now I'm going to multiply the 3x with the 5xy, but I'm going to keep it in parentheses because we got to be extra careful with the minus. So 4 times 3, that's 12, minus, parentheses, 3x times 5xy, I'm going to have 15 because 3 times 5. And then when I'm multiplying x times x, so that's x squared, and then the y, over 20xy squared. Now, I'm going to distribute my minus, so that way, I want to make sure I have the right sign for the term that I have here. So when I distribute, I'm going to have 12 minus 15 x squared y over 20 xy squared. Now here, I'm not going to worry about putting the numerator in order. I'm just going to leave it as 12 minus 15x squared y over 20 xy squared. Now, there's nothing I can combine in the numerator. Next, I check if I can simplify. There's nothing in common with the numbers 12, 20, and 15. And they don't have the same variables. And again, I have three parts: the 12, the negative 15x squared y, and the 20xy squared. Those are my three parts. All three parts don't have the same variable, so I can't simplify. Therefore, since I cannot simplify, this is my simplest form. So this is going to be my final answer. So just to review, I did this step by step, and I want to illustrate that, again, I put my 3x in parentheses so that when I'm distributing, I kept it in parentheses because you got to be extra careful when you have a minus. Once you finalize inside the parentheses, then distribute, so that way you have the proper sign for each respective terms. That way you can combine like terms properly and get the right answer.